The quest to find other worlds where life might thrive is one of humanity's most profound and exciting journeys. Today, we'll take you on a voyage to some of the most promising exoplanets that could potentially support life. Welcome to our exploration of exoplanets, the hunt for habitable worlds. Our first stop is Proxima Centauri B, orbiting the closest star to our Sun, Proxima Centauri. Just 424 light-years away, this Earth-sized exoplanet lies within the habitable zone of its star, where conditions might allow liquid water to exist. Proxima Centauri B is particularly intriguing because it's located in the habitable zone, where temperatures might allow for liquid water. However, its parent star is a red dwarf, known for high stellar activity, including flares that could strip away atmospheres and pose challenges to habitability. With a mass of about 1.17 times that of Earth and an orbital period of just 11.2 days, Proxima Centauri B could be tidally locked, meaning one side of the planet always faces the star, while the other is in perpetual darkness. This could create extreme temperature differences impacting potential habitability. Next, we journey 39.6 light-years away to the fascinating TRAPPIST-1 system. This system contains 7 Earth-sized planets orbiting a cool dwarf star. Among these, TRAPPIST-1e, F and G are situated in the habitable zone, making them prime candidates in our search for life. The TRAPPIST-1 planets are especially intriguing due to their potential to host liquid water. TRAPPIST-1e has a size and temperature similar to Earth. TRAPPIST-1f is slightly colder, but within the range for habitability. And TRAPPIST-1g, with its slightly larger size, could have a more substantial atmosphere. These planets' densities suggest rocky compositions, and they might have thick atmospheres and liquid water oceans. TRAPPIST-1e, for instance, has been modelled to potentially have an atmosphere rich in oxygen, and TRAPPIST-1f might have significant amounts of water. Further out, 500 light-years from Earth, lies Kepler 186f. This Earth-sized planet orbits in the habitable zone of its star, receiving about 1/3 the sunlight Earth does, suggesting it might have a temperate climate suitable for liquid water. Kepler 186f's environment might be very different from Earth's due to its lower sunlight, which could affect its climate and any potential photosynthetic life forms. However, its Earth-like size and location in the habitable zone make it a compelling candidate for further study. Kepler 186f is notable for being the first Earth-sized planet discovered in the habitable zone of another star. It has a radius 1.11 times that of Earth and an orbital period of 130 days, making its year comparable to our own. Next, we move to Kepler 452b, a super-Earth located 1,400 light-years away. This larger-than-Earth planet orbits in the habitable zone of a Sun-like star, raising exciting possibilities for its climate and potential to support life. Kepler 452b's similarities to Earth, combined with its orbit around a Sun-like star, suggest it might have a thick atmosphere and possibly liquid water. Its larger size could mean a higher gravity and a potentially thicker atmosphere, impacting its climate and weather systems. Kepler 452b is also interesting because it is about 6 billion years old, suggesting it could have a long, stable climate, providing ample time for life to potentially develop and evolve. LHS 1140b's density and mass suggest it is a rocky world with the potential to hold a significant atmosphere. Its position in the habitable zone makes it a key target for studying the possibilities of life beyond our solar system. LHS 1140b has a radius 1.4 times that of Earth and a mass of nearly 7 Earth masses, indicating a dense, rocky composition. Discovered via the transit method, it allows scientists to study its atmosphere by observing starlight passing through it. The search for habitable exoplanets is ever evolving. With advanced telescopes like the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, TESS, and future missions, our understanding of these distant worlds continues to grow. The search for habitable exoplanets is ever evolving. With advanced telescopes like the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, TESS, and future missions, our understanding of these distant worlds continues to grow. These powerful instruments allow us to study exoplanet atmospheres, climate conditions, and even search for biosignatures, indicators of possible life. The universe is vast and filled with countless stars and planets. Our quest to find another Earth is just beginning. Each discovery brings us closer to answering the profound question: are we alone in the universe?